Hello, welcome to this SBAC item video that I chose. As I was searching through the SBAC materials, this one came up and I figured it was a good one to chat about because this is a typical modeling with an expression, but this is asking you to create an equation. So, a good time to have a conversation too about that. But also, how can we represent this problem, make it more of a visual kind of understanding for students with GeoGebra? So this question says that a car rental company charges customers an initial charge plus a daily charge to rent cars. The initial charge is $30 and the daily charge is $25. So the rental company charged Jacob $180, so create an equation that can be used to find the number of days X Jacob rented the car. So I guess when I look at this question and as I'm kind of thinking again as I'm talking, a good discussion would be, when we look at a graph, we're comparing two quantities. And so getting, the class to discuss what the two quantities are is pretty important, is really important here. So the two quantities to me that are important here is the charge, right? So the charge, how much the customer is going to get charged for renting a car. And then also the variable is the days, right? So how many days did Jacob rent this car if he got charged $180? Okay, so when we look at a coordinate plane and we're relating two variables, and we can only look in the quadrant, we only need quadrant one for this pattern, then because we talk about independent variables being on the x-axis, this is going to become the number of days. And then this is going to be our charge or cost or whatever you want to look at it as, right? So what we can build is initially you're going to get charged $30, right, without even renting a car yet, so no days have passed, so we could look at 0, 30. And then let's do a slider that'll slide the number of days that Jacob rented the car and look at what that does to our charge at $30. Okay, so what I mean by that is, and let's just, to learn a little bit more about GeoGebra, I only want to look at the first quadrant. Which, be careful when you do that. If I right-click the screen, go to my graphics window, I can go to my x-axis and positive direction only, and do the same thing for my y-axis, positive direction only. Maybe I want my axes to be a little bit, make them bold, and we want to see our grid lines. So when I click on that, notice it's only going to give us that first quadrant. So I guess what I meant by be careful was sometimes if you set your minimum of your axes, you might not see your numbers, is what I was trying to get at. But now we can see that we have our x and our y-axis in the positive direction. We could go through the talk too of scaling the y-axis, right? We don't know how many days, but going by one seems to make sense to me. And looking at the charges, a $180 charge doesn't seem like a whole lot of days, so we don't really need to extend past here. But our initial charge is $30, so a couple things we can do. If you have your Move Graphics View tool selected, you can just hover over the y-axis. See how it turns your little hand turns into two arrows pointing up and down, which allows us to take the axis and drag it. And if I drag it towards the origin, notice our scale is going to change. Okay, so now we're looking at 30 to more than that if we wanted to. Maybe right now I'll just make it jump up by tens, and we'll just keep it like that, right? Now another thing we can do too, if we want kids to label their axes, if you right click your screen, go down to the graphics again, on the x-axis, it says label down here. We're going to call this number of days, and when I hit enter, we're going to get in the bottom corner here number of days, and it's subtle, but it's something for students to refer to, and also a good practice for them labeling things. So maybe this is going to be the charge in dollars, we'll say, right? So this is going to be the charge for renting the car. So now we got this set up. Okay, let's create our slider right now for the number of days that Jacob's going to rent this thing. So I'm going to grab my slider tool. I'm just going to put a slider somewhere. And I'm going to go with integer as my option, going from 1 day, which maybe we'll even make it 0 days. It's not an integer anymore. But we can call this 2 days, right? Or N for number of days, or D for days if you wanted to. GeoGebra does let you put in words for variables, which is nice. And we're only going to jump up by ones. So now our number of days that Jacob's renting right now based off our slider is going to be 1. Okay, and then we got 0. So now the math is really what's going to follow here. So how do we set up an expression of points so that as the number of days increases, we can watch our initial cost from $30 jump up by 25 depending on how many days, right? And we also want to compare the number of days to Jacob's $180 charge that he got. So we could look at a system sort of thing too with this. But to get kind of a conceptual understanding, to see where you're at, your students' math abilities, depending which teacher is watching this right now, whether you're elementary, middle school, high school, we have different needs for these types of problems and what we want to show. But I think that all kids could really benefit from setting up something like this, right? So we can talk about like, okay, 0 days have happened. There's a $30 initial charge. So that should tell us that based off of our problem here, our initial charge, so let's see here. So at 0 days, you're just going to rent the car now. You've got a $30 charge, right? For 0 days. Then after day 1, so after the first day, it's the $30 charge plus $25, right? Second day, we've got, which is 55 bucks. So after the second day, you got your $55 charge plus another 25. Or if you want to keep it at your initial 30 plus 25 plus another 25. And we can think about it that way if we want to. So as we go day 3, it's your $30 charge plus, and there's 225 charges, right? So now we're going to imagine 325 charges. And if we go through this kind of progression with the students, we can kind of see, what's variable, what's changing, and what's staying the same. So it seems like to me that if we write the value of a point, right, we want to see the actual relationship. So we have to come up with some x value for our point and some y value for our point, right? And to me, this is going to be the expression. This is what we're going to get out, except for setting 3, since this is what's changing, right? The 125, the 225s, the 325s. If it was 4 days, it'd be 4 $25 charges. This is what really is going to be our number of days, right? So we've got our initial charge of 30 plus $25 times the number of days, right? And then our x-coordinate is just going to be the number of days. So sorry if this is a mess in here. So let's go back to GeoGebra. Let's create a point. So I'm going to do my ordered pair down in the input bar. The x-coordinate is just going to be my days variable. So I'm just going to say days, comma. And then I'm going to write our expression here. And we had $30 plus the number of days times 25 bucks, right? $25 for each day. Now, one thing that you may want to do too, if you want to kind of make this more of a broader kind of example, maybe the initial charge changes, right? Maybe we don't want it to be $30. Maybe we want it to be 10, 25, 50, something like that. So what we can do too is create another slider. Maybe I'll make it another integer. Maybe not, maybe just a number. And I'm going to call this initial. So now we can say, well, let's let our initial be, let's say you got no charge. And then let's say the maximum we want to get charged maybe for a day, $200. And we want to jump up by dollars, which the integer would have done too. So now I have an initial slider. So what I can do back in my point here, if I want to change some things, I'm going to grab my move tool. I'm going to double click my point, which will allow me to redefine it. And if that doesn't work, depending on what version you have, you can right click. Oh, there it is. So my redefine, sorry, my tablet was slower than I was. And instead of the 30 here, Uh-oh. Sorry, my tab got a little non-responsive, but I think we're good here. So instead of 30, I'm going to call it my initial amount plus the number of days times $25, right? And I can click OK. And so now my initial charge was set to $1, but now I can move it back to the problem value, which is 30, right? So my initial is 30. There's our point. Okay, so maybe I'll make it a little bigger and we'll make it stand out. Okay, so there's my point there. So what we have in the math as our expression is showing that as our number of days increases, watch what happens to our point, right? So now 1 day, well, there's a $55 charge. 2 days is going to be more, right? So I'm going to, now if we want to change the scale again, you can grab that Move Graphics tool like I just showed you, or with any tool selected, if you hold Control on your keyboard, you can do the same thing just by it just converts any tool into a Move Graphics tool. So now we know that Jacob got charged $180. So I'm just going to slide this down here until I can see my $180 charge up on the screen. If I wanted to, I could put my y equals $180 so that we can see where we want the point to get to, basically. So the question is, how many days? So you can move your sliders by sliding it with your mouse, or if you have a tablet with your pen. Also, another nice easy way is if you use your left and right arrows on your keyboard, you can actually move your slider by one of your increments. So we can see as the days go on, then on day 6, it looks like we've got a charge of $180 with our initial of $30, right? Another nice thing, if you want to see the actual pattern getting graphed, right? Like that does a pretty good job there. But if you wanted to see where the point lands, you can right click on the point and just turn your trace on. If you turn your trace on, then it's just going to leave a little dot. It's going to leave a point where it was, and we can see this nice linear pattern. You can talk about slope, compare that to the $25 charge. Another nice thing too that we can do is if you want to make this even more general, right, then instead of the $25 charge, we could set that to be whatever we want. So maybe we can say rate, right, for your daily rate maybe. Let it be no dollars per day up to $100 a day, just making up some numbers. Okay, so we'll jump up by $1. Now when I go back to my point, double click that. I'll just right click it and go to object property. Here's my definition here. So we have initial plus days times 25. So now let's get rid of that times 25 and we're going to take it days times our rate. And now I'm going to hit enter and get out of here. It's going to change right now because my rate has changed. But now if I look at what happens when we change our rate too, kind of interesting. But let's put it back to 25. Here's my rate. If you want to clean your screen with the trace points on, 2 ways to go about it. I like shortcut keys. So if you do Control F on your keyboard, it'll refresh your screen. Or if you go to View, you can go to Refresh Views, and that's where that Control F came from. So you can refresh your view that way. So now we have, we had the general problem, but now we can set up all sorts of stuff. What if the car company charged you a different initial, a different rate, and then our variable still is days, right? You could then create some kind of system talk too. What if you had 2 companies that had some initial rate, some different daily rate, and then another company, compare which one would be the better deal, or what days would the one company be more expensive than the other, right? Those system kind of questions that we can ask. But kind of a neat way to get kids to understand the problem, and also variable and parameters, basically what's important here. Okay, so I hope that made some sense to you. Again, feel free to email me or put a message on this website if you have any questions or comments. Thanks guys, hope you enjoyed that.